Hello everyone. I'm going to explain chapter 4, which is relational model and normalization. So in this, I'm going to make two video clips for this chapter, and I want you guys watch the video clip, and I'm going to explain about the year assignment 7 later. Okay, so let's get started. So far we practiced drawing logical data modeling, which is using ER diagram. So the reason we need to understand the ER diagram, or the reason we have to practice to draw ER model or ERD is, with the ELD we have to design actual and real physical database tables. And this chapter will explain the intermediate steps to convert ERD to physical model. Okay, so I'm going to open this file. I'm going to open a file I designed before. So I have two entities, employees, jobs, and one relationship. So the termination in ERD, this rectangle is called employee entity. The rectangles, actually there's a curved here, but it is a rectangle. The rectangles in this ERD is called entity, and line which connects to two or more multiple entities with the crowfoot is called relationship. And well, the main idea of chapter 4 is quite similar to ERD, because you should be its model matched to the other form of model, and you should be able to it is possible to convert from ERD to EER notation and ER notation to ERD. Okay, let's get started. So through this chapter, I want you guys to understand those bullet points and terms and property of relations, and I want you to know how to main purpose and why we had to convert ERD to ER notation, and also I want you guys to understand how to normalize existing or new relations. Okay, so basically the ERD is drawn like many of ERDs are drawn like this, right? And your database tables, such as, let me open a table. So this model have to be converted to actual tables. We used to have a lot of tools to convert to ERD, to automated tool to convert ERD to tables, but you have to understand how manually the ELD will be converted to table. Okay, so let me open my tables. Okay, here we go. I have tables, and you also have same tables. So let me open employees table, and if you go to data tab, the columns data tab explains what columns you have and how many rows you have. So if you see the table, this screen, that you can easily figure out, the data format is two-dimensional, right? There are two axes, column axis and row axis, so that is two-dimensional. And this model needs to be, each entity needs to be converted to two-dimensional data format. The reason is, in column, in other words, these attributes have to be converted to column, and this entity, we can't contain actual data in this ERD, in ERD, but you have to consider your table will have multiple rows. In other words, you have your table. Main purpose of your table is containing actual data. Okay. So conceptually, to convert this model to table, attributes needs to become columns, right? Employee ID, first name, and last name have to be column. So attributes in ERD correspond with columns in table, and that will be name of a table, right? So to convert to ERD, we have to convert this ERD into a two-dimensional chart, but we don't have, when you create a new table, we don't have any data, right? And also, even if you have multiple data, multiple rows of data, we can't contain all of data into the two-dimensional. The reason is that we have very limited space, right? Let's go back. Well, we only have 3 columns here, but there are a lot of columns, and we have multiple rows. We should have maybe 206, and if you added new employees, then you may have five more employees. So we can't draw all employees in one chart. Just like ERD, the main purpose of main intermediate form, which is EER notation, is containing or should be able to explain how the entity will be converted and what relationships will have to be kept in the chart. So we're going to draw columns only. That we don't need to draw row in EER notation. So if I see the example, then you'll see you can easily figure it out. Okay, and also the main purpose. Okay, so let's go to notation. So this is an example of a EER notation. So in the top of rectangle, there should be table name customer, and you have to contain columns, column, and the primary key or unique identifier needs to have underline like this. So, and we can expect, if we have customer table in our table space, we'll have those columns, and we will have rows. We will have multiple customers with customer ID, name, address, city, state, and postal code, and we may have multiple rows. Oh, okay. So before I explain the remaining concept of ER notation, what I want to emphasize is it's one EER needs to, the information can be carried by one EER have to be atomic, and also every row must be unique. It may sound like obvious, but if you I just want to emphasize this concept and this key idea. The reason is when you convert ERD to EER, or when you draw ERD or EER, so it's very easy to forget those important requirements. So I want you guys to keep those in your mind. Okay, so let's go back to ER, and you may see your star, right? And you have to think about why there is star here, all right? And again, the primary key needs to have solid underline, and just like it, so customer ID in customer, and order ID in order, and order ID and product ID in order line. That means those two composite attribute plays a role of unique identifier. Okay, sometimes only one that is single unique identifier, but those are composite unique identifier. And product ID in product is unique identifier. And what about this? The disconnected underline refers foreign key. Okay, so that means order a customer ID in order refers customer ID in somewhere, but we have no idea what is the information source of customer ID for right now. But if you go to next page, page 10, then you'll see the line, curved line, or straight line. So this line indicates what is information source of those information. For instance, customer ID refers customer ID in customer, and order ID refers order ID in order, and product ID in order line refers product ID product. So that those are foreign key. That is foreign key, right? But order line, if you look at the order line, order ID and product ID are foreign key, which refers order ID and product ID and primary key at the same time. So sometimes composite foreign key may play a role of primary key as well. So when you need to convert to ERD, then you shouldn't forget the line. What is the information source? What is the reference of the foreign key? Okay. So if we write DDL based upon ER notation, then you have to code DDL like this. And we have done this kind of example, this kind of assignment with assignment 5, right? So we create if we do this this ER notation or an ERD is if those either ER or ER notation given, you should be able to write DDL. So let's see, that is the customer T name, right? But there's no customer T. The name is slightly different. The reason is this author of this textbook applies the naming rule. So in other words, that means if the names end with underscore T like this, customer underscore T, that refers table. So it is possible to see what is the object type just by seeing the name of object. So customer on T, there are columns: customer ID, name, address, city, and state, and postal code. But this author applies different naming rule to attribute. Normally, I have underscore between two nouns, right? If I were author, then I will give attribute name like this: customer underscore ID, customer underscore name, customer underscore address, customer underscore city, customer underscore state, customer underscore postal underscore code. But this author applies different naming rule. But I like the naming rule in the table name, like customer T, order T, and product T. And primary key, customer ID is primary key, right? And so we have no idea of the data type in ER notation or logical model of the ERD, but you should be able to guess what is the proper data type for each attribute, and you should be able to give proper constraint like not null primary key. And also this order line, let's see the order line here, and order ID, product ID, or ordered quantity, and those two composite attributes are primary key, and order ID refers order ID in order T, and product ID refers product ID in product underscore T table. Okay. So although we have a lot of tools to generate DDL, but you also need to know how to convert, how to write DDL based upon EER or ERD. Okay, so let's see. In this logical model, which could be similar logical model in textbook, it only shows primary key and attribute names and table names. But if you go to relational model, you will see data type, right? So the more specific information, the always better, such as primary key. We have, for instance, let's see, there is no job ID in employees, but we know employee refers job ID, right? As long as there is a relationship between employees and jobs, we can know what is foreign key here. But if you go to the relational model, there is information here: employees jobs foreign key, which refers job ID in jobs table. So the way to refer the information source in this with this application is slightly different, but way to reference the primary key is similar as well. Jobs ID, jobs underscore PK is constraint name of primary key for job ID in jobs. Okay, and just like job ID, employee ID is primary key, and this entity refers, and job ID, which is foreign key, refers job ID in jobs table. Okay, so if I give this logical model, then you should be able to convert EER notation, and also you either logical model or relational model, you should be able to convert to EER notation, and also you should be able to write DDL code for your assignment in your final exam. So converting between EER and ERD, or ERD to EER, is quite easy. But writing DDL couldn't be nothing for you. It could be slightly complicated than the other assignment, the other requirements. Okay, so all right. The later pages explains how to convert ERD model to EER notation, and that is called an entity in ERD, but this is called relation. Okay, not relationship. Relationships in ERD model explains what relationships are in between entities, right? But it could be similar, but that rectangle with table name and delimiter and column names called relation. Okay, so let's say you have ERD like this and again information have to be atomic. That means in ERD you may have multi-valued attribute, but multi-valued attribute shouldn't exist in relation. I'm sorry. So street, city, state have to be separated in notation in ERD model, EER notation. There shouldn't be any multi-valued, okay, or multi-valued. So, and let's say if there's multi-valued like this, then there shouldn't be multi-valued attribute in EER notation, and also there shouldn't be composite attribute. Well, I'm sorry, this is called composite attribute. Okay, but composite primary key is different. Composite primary key is refers the situation when two attribute plays a role of primary key at the same time. But composite attribute is an attribute containing multiple attributes like this. So composite attribute shouldn't be exist in EER notation. and it is okay in conceptual model, even if it is ERD. But you can't have any composite attribute, any multi-valued attribute in relational model. All attributes need to be separated. Composite attributes have to be separated. And what if you have multi-valued, like skills? Because employees may have multiple skills, right? And employees may have multiple skills. Employee needs to refer skills which will be separated from employees. So if I draw skills, then I will draw another entity here, skills. Okay. And skill, skill, maybe skill ID. Skill ID, and it have to be logical primary key, and maybe I'm going to give fixed length 4. Okay, and then skill name or description. And because its length have to be we shouldn't use fixed length. I decided varchar, which is variable length, and maybe 200 will be the maximum length. All right. And if I define relationship between employees and skills, it have to be actually many to many. The reason is, if you want to reuse skills entity, some other employees may have the same skills, right? And also, employees can have multiple skills. For instance, if you look at your resume, you may emphasize your skill: Java, Office program, and programming languages and database, right? And also, you can claim database is your skill after taking this class, after completing this semester. So let's say even if you just think about Java and database, you may have 2 skills, right? And also, Java or database can be claimed by multiple students or employees. So the relationship between skills and employees have to be many to many, right? And many to many. So, and I will I'll name a claim employee skills. Okay, well, even if I don't define attribute, I will automatically have primary key and foreign key in relational model. Okay, so you have to, and also have to be optional. So have to be optional. All right, and if I convert this model, convert this model to engineer to relational model, then I have relationship like this. Oh, it's strange. Source optional, yes. Okay, anyway. So there are relationships like this: employee skills and skills. And it explains what is the primary key and what is the foreign key here. So employee ID and skill ID and employee skills table, which is intermediate or bridge table, has those columns as primary key, and those columns are a foreign key at the same time. Okay, so what if I ask convert this model to EER notation? What if I ask you to write DDL with this model. You have to think about the case, okay? And if you see this model, it all attributes has a proper data type and maximum length, right? So again, what skills have to be multi-valued, but in this case, it's just so that it's multi-valued. But I think it have to be, well, if you want, that is only the case when you don't need to manage the skill types. So each claim, even if you claim, even if you and your friends claim the same skill, the skills for each student are different. Okay, so anyway, employee ID refers skills refers employee ID, and actually you should draw skills maybe notation here where I think it's skipped. So skills, if I complete this model, then let me draw a table. Okay, if I complete this model, then I need to skill and skill description. Okay, so looks fine, and forget the border. Maybe lines. Okay, I don't know how to. Well, I'm going to skip, but anyway. Okay, this looks nice, and I need to draw. Okay, so that is perfect model. Skills in employee skills refers employee ID in employees and skill in skills table, right? I need to write the name of notation over this rectangle, this table. But well, let me just skip. And this is perfect model to explain employees and employee skills and skills. Also, if the way to represent weak entity such as dependent is still employee's ID, independence refers employee, right? And first name, middle name, last name. You may think, what if there's this, those four composite attributes are primary key, and first name, middle name, and last name is primary key, or member of primary key. But you may think, what if they're same name of dependents? As long as employee ID is a member of primary key, you'll be fine, because in your family, no other family member can have the same name within your family, right? So that is why those normally names are not appropriate for primary key, but in this case it is fine. The reason is, again, employee ID is member of primary key. So if I consider all those four columns, we cannot find any case whose name are exactly same along with the employee ID same as well. So you may have another David. Well, let's say you have your brother, and you have brother, and your brother name is David, and you have the same name for family, right? But you can find other David in other family members, but employee ID is different. So any case will be fine. So, and employee refers employee ID and employee. And one to many, many to many, one to many, you can just draw one line. Okay. Let's see. So in many to many, well, let me just explain the one to many and one to many as well. So in this case, in ERD, you have to use crowfoot, right? You can simply draw arrow in EER notation. Let me find an example. You can draw the arrow like this. What if many to many? You have to always need to create a new relation. For instance, employee in a course, and the relationship between courses are many to many, and in the relationship, you may add more attribute like data completed, and in that case, this ERD cannot convert to EER notation without having bridge, which will certificate, and date completed, which is attribute of the relationship, will be another attribute or column in this notation. So whenever you have multiple many to many relationship, you always need to add intermediate or bridge entity or notation. This is key, this is the most important concept to convert logical ERD to ER notation. But if we use these kind of tools, then it will automatically insert bridge or entity like this. But that is the case when you allow to use application. Sometimes you have to draw ERD by your hand, and you also need to convert this kind of logical model to EER notation. In that case, you shouldn't forget that you must insert bridge or intermediate between many to many relationship. All right. Okay, so what if we do one to many? One to one. And there might be attribute even if you 1 to 1. In that case, see, nurse will be same. Nurse ID, nurse name, nurse birth date. Care center will have additional attribute. So there should be only two. In this ERD, there are two attributes. There are two attributes in care center, but when you convert this model to EER notation, date assigned will be added in this notation, in this relation, here. I'm sorry, and as long as care center refers nurse, care center needs to keep some information to refer nurse, right? So foreign key have to be added, and date assigned, which is additional attribute in ERD, have to be added like this. Okay, so I didn't empathize, but what you have to keep in mind when you draw ERD or ER notation is one relation or one entity needs to carry just one theme. In other words, order ID only contains order information, and customer ER or customer entity needs to contain information related to customer. But the only exception is about foreign key. Order ID, if you don't have a customer ID here, there's no way to refer customer. That means, in other words, without customer ID, we can't track, and we don't have any idea who placed this order, right? So that is the only exception. Foreign key is the only exception for one theme. Okay, so foreign key is out of is just one exception for one theme. So let's go back to the one to many, many to many, one to one. So regardless type of relationship, if there's a relationship between two entities or relationship between two relations, you have to keep foreign key at least one side, right? One side. So those two columns refers to tables, and even if one-to-one, even if it is one-to-one relationship, nurse ID have to be referred in somewhere as long as there is a relationship. So this is why care center keeps nurse ID. Okay, but sometimes you may have different ID. You don't need to keep the same column name. You can have different column name, like nurse in charge. So that is, well, that sometimes called, I normally call it is intermediate or bridge, but normal the official terminology is an associative entity, which replace many to many relationships. Okay, so let's go back to here. So in the logical model, you may draw. Okay, let's draw an ERD, which explains relationship between order and product. I'm going to draw in two ways, right? So let me draw order, and this entity needs to have two attributes: order ID, and have to be primary key, maybe. Well, I don't need to decide, but data type. But I'm going to decide it. Data type. Maybe 10. Normally, order ID is longer than 10. Okay. I forgot it. I forgot order date. Date. Okay. And product. Product description and finish and standard price and line ID. Product standard price. You have to be a number, right? Numeric, and scale maybe 8, and precision is 2. Actually, this column needs to refer product line ID in product line, but that is out of topic. So I'm going to draw order and product and order line only. Okay, so as I've said, mentioned before, I'm going to draw in two ways. Okay, I will copy and paste here, right? The first case is when you just define the relationship between order and product is many to many. Okay, many to many have to be, well, I think it's optional, and order product, and I'm going to give this its name as order line. Okay, we'll just add ordered quantity. Ordered quantity. And have to be number, right? And maybe 2-digit and 4-digit will be enough, because the number have to be integer. So we don't need to we don't need to allow fractions. But we already know we can't. I need to because I just copied and pasted. I have slightly awkward name, but you have to consider those order, another order, and another product. So we already know we can't have any many-to-many relationship in EER notation. So you have to use the function to engineer or convert to logical model to relational model, or you have to draw associate entity between here, or intermediate or bridge. So I'm going to use offshore term, but I normally use bridge. So let me add bridge between order and product. Okay, so let me add bridge here, and it will be order line and there should be order quantity. Okay, and have to be number and 4. Okay, so when there is many-to-many, let me show you how to insert bridge without using the function of any application. What you have to do is this many needs to go to bridge side. Okay, and that one have to be many in the many-to-many relationship. In other words, if you want to insert bridge here, you have to insert between them, and many will need to attach you to a bridge. And you get these two entities will have one cardinality. All right, so that means one too many and one too many. Okay, easy, right? This many goes to here and this many goes to here, and you have to the reason is we have to convert many to many to one too many, right? So one many to many will be converted to bridge or associative, and to one too many relationship. But we have to check optional. Okay, and order line needs to refer. Okay, and anyway, you will see many to many relationship can be converted to associated with to one too many relationship, and I'm going to engineer this model to relational model, and we'll see what's difference, what are different from each other. Okay, so let me convert it. Okay, so if you just recognize what I'm said in Korean, just neglect, because I said it's annoying, because while I really don't like receiving phone call or receiving text or email while I record this video clip, but I just got a lot of multiple text and phone call and email, so that's why I said it's really annoying in Korean. Okay, so let me just engineer. All right, okay, I just engineered. Okay, so okay, there's actually the difference. Let me give optional and give optional. I'm sorry. Let me engineer again. Then you cannot find any difference between two ways. There is difference. I'm sorry, I need to uncheck it. Okay. Alright, so first one is converted from this one with just many to many relationship, and this one converted from the second method with bridge. So you cannot see any difference between them, right? Order line. Oh, did I forget the order quantity in order line? I think, yeah, I forgot it. That is my order. Well, anyway, ordered quantity have to be added as an attribute in this relationship. But if you don't forget it, then you will have order quantity like this in this entity. So that's the only difference I made. And order date, order ID, same, right? Order ID, product ID, same, except for order quantity. And the other information are exactly the same as well, right? So it is possible when I ask you to convert. Well, I may not ask you to you convert to many relationship to multiple one-to-many with bridge, because you are able to use application. But what if I ask you convert to one-to-many and many to many to multiple one-to-many with bridge for your exam? You should be able to draw by yourself using paper and pencil, right? Also, this will have to be this model needs to be converted to EER notation like this. That's why, well, to show this one, to show this chart, I just draw. I just explained in two ways, right? Anyway, order ID, product ID, and refers order ID and product ID, and you have to add one attribute more, additional attribute, because you have bridge this attribute in your bridge, right? Okay, so just like this, you can add one associative entity if there is a many-to-many relationship between customer and vendor, and in that case, the many needs to go to associative or bridge, right? And as long as shipment refers customer and vendor ID and customer ID needs to be foreign key in shipment, although we don't see customer ID and vendor ID in shipment, right? But we all know we know shipment refers customer and vendor. To refer customer and vendor, customer ID or vendor ID, customer ID and vendor ID needs to be kept and recorded in any ways in shipment, right? So we have, that's why we have customer ID, vendor ID. Okay, so and even if there is a self join or unary relationship like employees, manager ID is foreign key and manager ID needs to refer employee ID. So see, and the relationship between managers and employees one to many. So one to many is fine in EER notation. EER notation is an intermediate way to explain the actual column, how the actual columns will be shown in the actual tables. So let me skip a ternary. Well, you can have for ternary you can insert a bridge to explain three multiple entities: patient, physician, and claimant. So many to many in binary or ternary needs to have associative in EER notation. So I think it is better to have it to draw, not to. It's better to have it not to have any many to many or any ternary in even if you logical ERD. So in that case, anyway, if claimant refers physician and patient and claimant, and it needs to refer those three other relations. Okay, so I think I'm done to explain how to convert to ERD to EER, and I also explained why we shouldn't have any many to many relationships or ternary relationships, because those are useless anyway, and also anyway it have to be converted to bridge or associative form. Okay, so I recommend you guys not to have any many to many relationships and ternary, right? And I'm going to ask you not to have any many to many, or I may ask you to convert to many relationships to one to many with bridge or associative entity or associative relation. Okay, so thank you for watching this video, and we'll see you guys in the next video clip.